Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
I'm here. Thank you all so much for joining me. I am so glad that you're here for Math Wednesday. I think we've been doing this for about 8 weeks now, and I look forward to it every Wednesday, as I hope you do too. So before we get started, what I would like for you to do is post in the comments section where you're from and what test you're prepping for. That's going to help me kind of gear. The questions are pretty much set, but it's going to help me gear my explanations and the kind of the direction I go with those questions. So leave me in the comments where you're from and what test you are prepping for. While we're at it, I'm from Central Florida area, and I am so glad that you're here. Yes, I live kind of near Disney. I'm about 45 minutes away from Disney, but probably haven't been to Disney in like 5 years. So we do not go to Disney all the time if we live in Central Florida. Some people do, but I don't. With that said, let's not waste any more time. Let's go ahead and get started with our first question. Now, like Dr. A said, we will be covering content from pre-K through 12th grade math tonight. So I know some of you are going to be prepping for your pre-K through 3 math, K through 6, Praxis Core, GK math, 6 through 12 math, middle school math. There's a lot of different exams that we're prepping for. So like I said, I will be going over a variety of questions. Some of them are very specific to some of those grade levels, and some of them are much more general, which will allow us to hit the most amount of people at once. And those are the kinds of questions that I really like to do because we've got a variety in here. Hello, everybody. I see someone's from New Jersey. You probably have much better weather than we do right now. It's like a heat index of 106, 108 every day right now. Utah, getting ready for the Praxis exam. I'm guessing you're getting ready for the Praxis Core. Florida, the math 6 through 12. That's amazing. The K through 6, we've got a variety in here tonight. Welcome, welcome. I will give you a disclaimer. If you hear my dog barking, we do have a very large dog. He's a Great Dane. He likes to bark at all the squirrels outside, so I apologize in advance if you hear him. All right, let's get started. It does say problem 2. This is technically problem 1. We're actually going to skip problem 1, and we're going to come back to that one if we have time at the end. So let's go ahead and jump right into problem 1, 2, whichever one you want to call it. New Mexico Praxis score. Hey, Hope, I recognize you. You have been here a couple of weeks, so I'm so glad that you're back. So let's get started. If you want these questions emailed or texted to you, feel free to text the number that's going to show up on the screen right here, and you will get a clean copy of all of these questions that we are going to do tonight. All right, let's go ahead and get started. A 2-inch wide wood frame is to be designed around a painting that is 3 feet by 4 feet. If the wood costs $2 per square inch, how much will the frame cost? So this is a really interesting question, and this is really going to apply for anybody K-12 because this hovers right in that 5th, 6th grade range, and core, GK, middle school, and high school love these kinds of questions because it really ensures that we are understanding a scope of concepts. And what I really need you to understand as you're studying for these exams, I need you to understand that questions are not going to just point blank ask you, what is the Pythagorean theorem? How do you find area? What is the area formula? A lot of the questions are going to scope a lot of different concepts all in one question. You really have to understand a bunch of different concepts at once. So in this case, we have a 2-inch wide wood frame that's being designed around a painting that is 3 feet by 4 feet. Let's go ahead and draw a picture of what this looks like, because anytime we're doing a problem like this that's geometry related, it's always good to draw a picture. So we have a painting that is 3 feet by 4 feet. And I'm just going to draw a human inside here to show us that this is our painting. And they're asking us to put a frame around this painting. So I'm going to do the frame in a different color. We have a 2-inch frame going around this painting. So here's my frame. I'm definitely not an artist, if you can tell. I'm definitely a mathematician. Okay, there's our frame. And it's asking us, what is it asking us? That's the first thing we want to go to every single time we're solving a problem. We want to understand what this problem is. We want to figure out what we're doing. We want to problem solve it, and then we want to solve it. So we really need to understand the problem, make a plan, and then solve it. So how much will the frame cost? So we're looking for the cost of this frame. But what other information did they give us? They told us it costs $2 per square inch. What do I know about square inches? Square anything, centimeters, meters, inches, miles. Square anything is going to be area. If they give us square inches or square anything, it's going to be area. So we have to find the area of only the frame, not the painting. We don't need to know what the area of this painting is because that's not going to be included in the cost. We need to find the area of just the frame because that's what we're paying for the wood. So how do I find the area of that? The easiest way to find the area of a frame, and I'm telling you, frames, decks, all of this kind of stuff is, I see it a lot on prep material. We like to make 4 rectangles. So I'm going to cut this frame into different rectangles that I can find area of, because I don't have an area formula for a frame, but I do have an area formula for a rectangle. Area of a rectangle equals length times width. So I can cut this frame here, and I can cut this frame here, and I can cut this frame here, and I can cut this frame here. What did I just do? I created a rectangle right here, a rectangle right here, a rectangle right here, and a rectangle right here that I can find the area of. So I have 4 different rectangles that I'm going to find the area of. Here's the other problem. We were given feet for the painting, but they're looking for the cost in square inches. So I have to convert those feet into inches. So I know that 1 foot equals 12 inches. So therefore, 3 feet is going to equal 36 inches. 1 times 12 is 12, 3 times 12 is 36, 4 times 12 is 48. So instead of 3 feet, I'm going to call this 36 inches. And instead of 4 feet, I'm going to call this 48 inches. Now I think we're ready to go. We know it's a 2-inch wide frame. So I know that this distance right here is 2 inches. I also know that this distance right here is 2 inches, 2 inches, 2 inches, 2 inches, and then this is 2 inches as well. So what are the dimensions of my 4 rectangles that I'm looking at? I have this I'm going to change colors here. I have this rectangle right here. That rectangle right there is going to be 48 inches, and then the frame is 2 inches big. So by 2. 48, can't see that. 48 times 2 give me 96. So this rectangle is 96. Well, what does that mean for the top rectangle? The top rectangle is 96 inches squared as well. Here's the tricky part, and I get questions about this all the time. What is the area of the other 2 rectangles? Well, it's not 36 times 2 because this right here is 36, but I have this extra length, and I have this little bit right here, and I have this little bit right here. So I have to add that extra little bit to my length. So what I have is I have 36 plus 2 plus 2. 36, 37, 38, 39, 40. So my length is actually going to be 40, which is this whole thing. And then my width is still 2 because this or this or this, doesn't matter where you look, is going to be 2. 40 times 2 is 80. And 80. Why didn't I add that amount to the other rectangle? Great question. Because the way I chopped my frames up, I didn't need to. The way you chopped your frames up, you might have done your painting, and then you had your frame, and you might have chopped your frames this way. And in that case, you would have had to add 2 to the other dimension. And that's okay, it doesn't matter. So now I need to add all my areas together. 96 plus 96 plus 80 plus 80. 96 plus 96 plus 80 plus 80 is 352 inches squared. You notice that that's one of the answer choices. That is not our answer, because what does that number give us right there? That number gives us the area of the frame. It doesn't give us the cost of the frame. The cost of the frame is $2 per square inch. So if this is the number of square inches I have to take that and multiply it by $2, which is ultimately going to give me $704. That was a lot of explanation. That problem should not take you that long. But like I said, I like to make sure that I'm explaining it through. For those of you who are just joining us, welcome. Go ahead and text Math Stream 1 to the number at the bottom of the screen, and you can get a copy of these slides and these problems that we're doing tonight. All right, if you have any questions as I'm working through these problems, feel free to post a comment, and I will be happy to answer any questions you have as we go through tonight. So don't hesitate to ask me any questions. Drop a comment, let me know what questions you have, and I will answer them to the best of my ability. Let's move on to problem number 3. Which of the following best describes the faces of the following figure? 2 equilateral triangles, 1 square, 2 rectangles. 2 isosceles triangles, 1 square, 2 rectangles. 2 equilateral triangles, 3 rectangles. 2 isosceles triangles, 3 rectangles. This question is perfect for pre-K through 12 because it's very, 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 very important that everybody knows the terminology in geometry. You got to know how to classify shapes, and you've got to know like the properties of shapes. So let's just go over some important vocabulary that we see in this problem. We see equilateral. We see isosceles. We see square, rectangles, and triangles. So let's quickly define all of those vocabulary terms. So triangle. A triangle is what? Any three-sided shape. A rectangle is a four-sided quadrilateral, which that is an oxymoron because four-sided and quadrilateral are the same, but it's a quadrilateral or a four-sided shape that has 2 sets of parallel lines and 90-degree angles in the corners. So it's a quadrilateral with 90-degree angles and 2 sets of congruent parallel sides. That's a lot of vocabulary in one definition. And then a square is going to be a rectangle, except it has 4 equal sides. So it is also a quadrilateral with 90-degree angles and congruent parallel sides. But it's going to have, so it's a quadrilateral with 90-degree angles and 2 sets of congruent parallel sides, but it's really going to have 4 equal parallel sides. So not all the sides are parallel, but all the sides are equal. Now let's talk about equilateral and isosceles. These are vocabulary terms that we only use when we're describing triangles. An equilateral triangle has equal sides and angles. That makes sense. Equilateral, equal. An isosceles triangle has 2 equal sides, exactly 2 equal sides. Not more than, not less than. It has exactly 2 equal sides. So now let's go look at our shape and let's define the shape that we have. This is where a lot of people get confused. This right here is a prism. But we can compare prisms and pyramids. A prism has 2 equal bases with rectangles surrounding the shape to close the shape off. A pyramid has 1 base with triangles extending up to 1 vertex. So when we talk about, and I need to add a page here so I can show you. I'm kind of rabbit trailing, but I did this question on purpose because I wanted you to see all of this geometry vocabulary. So a prism could be a rectangular prism. It could be a triangular prism. It could be a hexagonal prism. I could have a hexagon, absolutely. And what you notice that's the same about all of these shapes is we have 2 equal bases and then we have rectangles surrounding it. A pyramid is going to have 1 base and then triangles extending up. So the number of triangles is going to equal the number of sides on my base. So this base is a rectangle. So it's going to have 4 triangles going up because I have a triangle on this side, a triangle on this side, a triangle on this side, and a triangle on this side. I can have a triangular pyramid. Same thing. I have a triangle on the bottom and then a bunch of 3 triangles going up. A prism is kind of the same in the sense that if I have 2 equal bases and rectangles around it, the number of rectangles I have is going to equal the number of sides on my base, because this side is going to have a rectangle, this side is going to have a rectangle, this side is going to have a rectangle, this side is going to have a rectangle. You see where I'm going with that. All right, let's go back to our actual question. So, which of the following describes this shape? Well, I have a prism here. What do I know about a prism? 2 equal bases. So even though I can't see that other base, I know that it's there and it's going to be the same as this, because this shape is a prism. It doesn't come to a point. So I'm going to have 2 equal bases. Then I'm going to have 3 rectangles going around it. So I see 3 rectangles here and I see 3 rectangles here. They could be squares too, but there's no answer choice where it's 2 triangles and 3 squares. It's 2 triangles, 1 square, 2 rectangles. I don't know that any of those are squares. I know that they're all rectangles. So A and B are out. 2 equilateral triangles or 2 isosceles triangles? I'm going to challenge you guys who are watching. What kind of triangles are we looking at and why? What kind of triangle is this and how do I know? I'm going to give you a minute to think about that. What kind of triangle is that and how do I know that that's that kind of triangle? That is an equilateral triangle. How do I know? Because of these little congruency sticks. Those congruency sticks mean that all of those sides are equal. If I only had a triangle like this and they only had a congruency stick here and here, that would mean that it would be an isosceles triangle because only these 2 sides are equal and not the bottom. But because all 3 of them have the congruency sticks, it means that they're all equal. I also know that they're all equal because they labeled this as 60 degrees. And if this side is 60, then this angle is 60 and this angle is 60. 60 plus 60 plus 60 is 180. So this is an equilateral triangle, which means C is our correct answer. That's a lot of vocabulary. That was a ton of information, but it's all super critical if you're going to be successful on the geometry part of your exam. And every single one of you in here is going to have a geometry part of your exam. Excellent job. Let's go ahead and keep moving. All right, I have a 4A, a 4B, and a 4C coming up because I really wanted to hone in on geometry vocabulary today because it's so important for our GK, Praxis Core, K through 6, middle school, and high school. Because if you don't understand the GK or the geometry vocabulary, then it's going to be really hard to solve multi-step problems that involve geometry. So, which of the following geometric figures must have perpendicular diagonals? Now, this is a question you'll see on a pre-K3, K6, maybe GK and core. However, my GK, core, middle school, and high school people, if you don't know this, then you're not going to be able to solve more complex problems where you're having to apply this. And I'll show you an example of that in a minute. Which of the following figures must have perpendicular diagonals? A quadrilateral, a square, a rectangle, or a rhombus? Well, we know a quadrilateral is a shape with 4 sides. Could it have perpendicular diagonals? Yeah, it could, but it's not a must. So that's automatically out because there's a lot of different kinds of quadrilaterals. We have trapezoids, we have rectangles, we have squares, we have parallelograms. I mean, I could go on and on with quadrilaterals, but they don't have to have perpendicular diagonals. A square, a rectangle, or a rhombus. So let's just conceptually think about this. I like to be really dramatic when I draw my shapes for this purpose. So let's draw a square. I can't be dramatic when I draw a square because a square has equal sides. Those kind of look like they could be perpendicular, but I never, ever, ever want to base it on a kind of looks like. Let's draw a rectangle. And like I said, I like to be super dramatic when I draw my rectangles, and you'll see why in a minute. And let's draw our diagonals. Is there any planet that is going to be, I can't even get them straight, that is going to be perpendicular? No, there's no planet where that's perpendicular. First, we need to know what perpendicular even means. Perpendicular means intersects at 90 degrees. And so when I draw a regular rectangle, like maybe one that looks like this, you may not be able to visually see it. But when I draw something like this, it's very obvious that that is not a 90-degree angle. So I can eliminate rectangle just based on that silly drawing that I just did. Square and rhombus, they're actually both correct. A square and a rhombus both have perpendicular diagonals. So in this case, it should have said choose all that apply, and it doesn't. It should have said that. Square and rhombus. So a rhombus is like a tilted over square. It has equal sides, but it does not have to have 90-degree angles. So a rhombus has to have equal sides, but it doesn't have to have 90-degree angles. A square has to have equal sides and 90-degree angles. So a square and a rhombus both have perpendicular diagonals. Now, middle school and high school people, you stuck with me for all of that explanation. Why is this important for you? Because you might have a circle with a square that's inscribed inside of it with diameters cutting through it. And there's all sorts of questions they could ask about this shape. But it's important that you know that these are perpendicular to each other depending on the question that they ask, because they might ask, they might give you the length of the radius, and they might ask you what the length of this side is. If you know that the length of this side is, let's pretend 9, and they say the radius is 4, and you know that this is a square because they have the congruency symbols on it, because I know that the diagonals are perpendicular, I know that I can use Pythagorean theorem to solve for the other side. Okay, so let's actually say they didn't give us, let's actually say they didn't give us this right here, and they said the radius is 4. So if I know that this is 4 and I know that this is 4, because those are both radii, and I needed to solve for the side of the square, I would be able to do that because I know that these are perpendicular by diagonals. And I know that with that, I can use Pythagorean theorem because I can only use Pythagorean theorem on a right triangle, and I know that that creates a right triangle. So where they may not ask you this exact question, if you know that information, it's going to make your life a lot easier when you're solving much more complex problems like this. For those of you who are just joining, welcome. I'm so glad that you're here. Let me know in the comments where you're from, and let me know in the comments what test you're prepping for. And if you text the number right here, MathStream1 to 407-269-8829, you can get a copy of these slides for the problems that you may have missed. All right, problem 4B. Very similar problem here, you'll notice, but it's important that we know these properties. Which of the following geometric figures must have 4 equal sides? Quadrilateral, parallelogram, rectangle, or rhombus? Well, let's talk about each of these shapes. And if you were here for the last problem, you should be able to define some of these shapes. Quadrilateral is a 4-sided shape. So it doesn't have to have 4 equal sides. It's just any 4-sided shape. So it's definitely not quadrilateral. Parallelogram is a quadrilateral with two sets of congruent parallel sides. All that means is that in a parallelogram, it has a set here that's congruent and a set here that's congruent. And so the top and the bottom are equal and the sides are equal. The top and the bottom are parallel from each other and the sides are parallel from each other, but they don't have to have a 90-degree angle. And so a parallelogram does not have to have 4 equal sides. Rectangle is a quadrilateral with 2 sets of congruent parallel sides and 90-degree angles. So it doesn't have to be a rectangle either, because that's congruent, and these are all 90, but those are not 4 equal sides. So a rhombus is the only shape it can be, because a rhombus has 4 equal sides, and a rhombus is a parallelogram as well, because it's a quadrilateral with 2 sets of equal parallel sides, but it's going to have 4 equal sides. The only difference between a rhombus and a square is the lack of 90-degree angles. All right, I have one more of these for you, and then we'll move on from geometry. We're going to move into some algebra after this. Which of the following geometric figures must have perpendicular edges? Ooh, this is a good one. Perpendicular edges. So we've already, you know what? I'm just going to copy all of this because there's no use in rewriting it. Copy, paste. Hey, look at that. A quadrilateral is a 4-sided shape. A parallelogram is a quadrilateral with 2 sets of congruent parallel sides. A rectangle is a quadrilateral with 2 sets of congruent parallel sides and 90-degree angles. And a rhombus is a quadrilateral with 4 equal sides. A quadrilateral, that didn't work. Oh well. A quadrilateral with 4 equal sides. So which of these has to have perpendicular edges? It's going to be our rectangle, because the rectangle is the only one with 90 that's required to have 90-degree angles. All right, let's move on into some algebra, because that was enough geometry for one day for me. All right, which of the following is which expression is equivalent to the following? Now, this kind of problem is not going to be on K6. It's going to be on our GK, Praxis core, any 6 through 12, any math 5 through 9. But my math K through 6 people, I'm going to talk through some things that you will need to know, even though this kind of problem isn't going to be on your test. So here we go. If we're trying to simplify this expression, I'm going to use the distributive property. Everybody needs to know that. Distributive property says that if I have a set of parentheses with something inside, an expression or some sort of, set of numbers, then I'm going to go ahead and multiply what's on the outside through the entire thing, as long as there's not a plus and a minus in between it. So if it said something like this, then I would not distribute the 7/4 all the way through because it's being added. But because it's being multiplied, I am going to go ahead and distribute it all the way through. So I'm going to distribute my negative 7/4 all the way through. So I have negative 7/4 times negative 8x squared plus negative 7/4 times 12 over 21x. Now, depending on the test you're taking, you might get a calculator, which is going to come in super handy for a problem like this. But I'm going to pretend like we don't have a calculator because some of you are not going to have that luxury. So I know a negative times a negative equals a positive. This is how I like to remember that. Negative times a negative makes a positive. Negative times a negative makes a positive. So when I multiply these two things together, I'm going to end up with a positive something. 2 different ways I can do this. I can multiply the numerators together, so I can put the 8 over a 1, and I can multiply the tops together, and I can multiply the bottoms together, or I can cancel before I do that. I'm going to go ahead and multiply first. So -7 times -8 is 56, divided by 4 times 1 is 4, x squared. Plus, and again, elementary people, you need to know how to do that. Multiplying fractions, being very comfortable with that. You may not need to know how to simplify an expression, but that basic understanding is something you will need to know. Then negative times a positive is actually going to be a negative. So I'm going to change this positive into a negative. -7 times -12 is -96. No. -86. Tried to do that in my head. That didn't work. And 21 times 4, that is not even 86. I should be not doing that in my head. 12 times 7, 14, 84. Goodness. 4 times 1 is 4, and 2 times 4 is 8. So 84 over 84x. Now I can simplify. 56 divided by 4, and again, I could use my calculator, but I'm not going to because not everybody in this room is privy to the luxury of a calculator. 4 goes into 5 one time. 4 goes into 16 4 times. So I end up with 14x squared. 84 divided by 84 is 1, so -1x. I do not need to keep that 1 there. That is a question I get a lot on our Facebook page. Why is there no 1? Why is there a 1? The 1 is not necessary in front of a coefficient. So I can actually eliminate the 1 and it can just be an x because it's an imaginary 1. So the answer is going to go ahead and be D. 14x squared minus x. Just that simple. All right, let's keep going. Remember, if you have any questions at all, please drop them in the comments and I'll be more than happy to answer. Another kind of disclaimer, it's not really a disclaimer, but if you have, like at the end of tonight, if you're like, man, I really wish she would have gone over linear functions, or I really wish she would have gone over symmetry, or I really wish she would have gone over a little bit more of that expression kind of thing because I don't really get that, please let me know in the comments because I build our problem sets around what you guys need. Otherwise, I'm just pulling random problems, which is fine. I'm more than happy to do that, but I would rather tailor the experience to what you guys need. So feel free to drop in the comments what you need from me next week in next week's session. All right, problem 6. This is specifically for my pre-K through 3 people because I always like to make sure I have a problem that's very specific to you. Everybody needs to know this vocabulary, but this is a problem you would typically see on pre-K through 3. In the number 5,734,982 and 106 thousandths, what number is in the hundredths place? 9, 7, 1, or 0. So let's just do a little place value review. If you already know how to do this, just stick around because there'll be a problem next that you'll need help with. So if we have a decimal, anything on the left are our whole numbers. So this is going to be our ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, and it keeps going. 10,000s, and it could keep going on forever. On the right of our decimal are going to be our decimal numbers. So this is going to be our tenths, our hundredths, our thousandths, 10,000s, 100,000s. Now, where people get confused is they think because there's a ones and then a tens, that there's a oneths and then a tenths, and that is not the case. This first blank is the tenths. So if we're looking for the hundredths place, we're actually looking for this place right here. So what number is in that place in our number? It's going to be the 0. Let's talk about what place value the 9, the 7, and the 1 are. 9 is going to be in our hundreds place. 7 is going to be in our hundred thousands place. And the 1 is going to be in our 10ths place. So that's just a little quick place value lesson. Let's keep going. Ooh, transformations. I love transformations. Which sequence of transformations will map rectangle A onto its congruent image rectangle B? This kind of problem tricks people because of the words, not because of the actual concept. So let's break this problem down after I read these answer choices. A reflection over the y-axis, then a reflection over the x-axis. B, a translation 6 units down, then a reflection over the y-axis. C, a reflection over the y-axis, then a translation 4 units down. Or D, a rotation 180 degrees clockwise about the origin, then a translation of 4 units to the right. So this problem is interesting. We got to know some key vocabulary. I'm sick of the salmon color. All right, so congruent image just means the same. So image A is the same, and I should have labeled this. I apologize. That is A and this is B. So in a normal problem, they will label the images A and B for you. So we've got A and we've got B. Let's talk about what a reflection, a translation, and a rotation mean. Because we got to know the difference between a reflection, a translation, and a rotation. A reflection, I like to think of as like a mirror. So which one? Uh-oh, we lost our connection. Let's try that again. Olga, which one is A? I just answered that question, but I really appreciate you asking that because that would have drastically changed how the problem was. It would have changed which direction that we are reflecting. So that's absolutely a great question. So A is the top one, B is the bottom one. All right, a reflection I like to think of as a mirror. So if I'm looking in a mirror, I'm as far away from the mirror as the mirror thinks I am. So if I'm reflecting this image A, and let's just reflect it over the x-axis first, where this is the x-axis and this is the y-axis. Because it is 1, 2, 3, 4 units away from the x-axis in the positive direction, it has to be 4 units away from the x-axis in the bottom as well. So I'm going to go 1, 2, 3, 4, and I have A. Oh, I made that a little too long. So that is A reflected over the x-axis. Again, reflection is kind of like a mirror. A translation is really more of like a shift. So I'm just pushing A to the left or the right. So a translation 6 units down, I'm just going to push A 6 units down. 1, 2, 3, 4, 5, 6, and A would land right here. So that's a translation. And a rotation is exactly what you think. I'm literally rotating it, and it says about the origin, where this is the origin. So I'm literally rotating it 180 degrees. So let's go ahead and look at our answer choices and kind of talk about what each of these is going to be. Reflect over the y-axis. So that's going to put it right here. How did I know that? Because it's 2 units away on this side, so it's going to be 2 units away on this side. And then a reflection over the x-axis. The then is critical because it tells you what you're doing first and then what you're doing next. So now I'm going to reflect it over the x-axis. 1, 2, 3, 4. 1, 2, 3, 4. I land right there. So A is actually our answer. Let's talk about where it would land if we did B, C, and D. All right, letter B. A translation 6 units down and then a reflection over the y-axis. So let's shift it 6 units down. 1, 2, 3, 4, 5, 6 would put it here. And then a reflection over the y-axis would put it right here. So that's not the answer. a reflection over the y-axis and then a translation 4 units down. Well, we already reflected it over the y-axis here, and then moving it 4 units down, 1, 2, 3, 4 would put it right here. All right, are we seeing that? Rotations. Rotations are something that are difficult. It's kind of hard to visualize where it would land if we're rotating. So we have some rotation about the origin rules. We have some rotation about the origin rules. And these are rules that if we have an XY point and we rotate it 90 degrees, it would become something else. So rotation rules, and this may be something that you want to take a picture of, because when you get the slides, like when you text this number, you don't get the notes. So this is definitely something that you may want to take a picture of. So if I have an X comma Y and I rotate it 90 degrees about the origin, then it's going to translate into Y, negative Y comma X. If I have an X comma Y and I rotate it 180 degrees about the origin, it's going to turn into negative X, negative Y. And I'll show you what this means in a minute. If I had an X comma Y, I see your question, Elisa, and I will go ahead and answer that here in a minute. If I have an X comma Y, and I rotate it 270 degrees about the origin, which is just 90 plus 90 plus 90, it becomes Y comma negative X. So those are important. So if this is my point, that point is 1, 2, 3, 4, 5, 6, comma 1, 2, 3, 4, 5, 6, 7. And I rotate it 180 degrees. Let's take a look at that 180 degrees. It becomes a negative X, negative Y. So this point would become negative 6, negative 7. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. It would land right here. I have a feeling it's going to land on top of B. And then there's a translation that happens after that. So you got to know those rotational rules, middle school, high school people, for sure, so that you can go ahead and understand how to do that without trying to visualize that. Why is it not 8 down? Never mind reflection. It would be 8 down if we were reflecting and then translating 8 down. But because we reflected and then reflected again, it landed on top of B. So excellent question though. Excellent question. Translating it 8 down would have worked as well, but that wasn't an answer choice, unfortunately. And because the reflection was 4, it was 4 on top and 4 on bottom, it worked. Thank you for asking that. I'm sure somebody else was curious as well. All right, let's keep going. What is the value of angle A? This is an interesting one. This one is important for everybody. So especially my middle school, core, GK, high school people. So in order to be able to figure out what A is, we have to know what the sum of the interior angles is of this shape. The equation for sum of interior angles is n minus 2 times 180, where n is the number of sides in your shape. So because we have a pentagon, we're going to do 5 minus 2 times 180, which is 3 times 180, which gives us 540. So that means that angle A plus B plus C plus D plus E all have to equal 540. So let's go ahead and just set that up. A plus B plus C plus D plus E equals 540. First thing I'm going to do is go ahead and combine all of my constants together. So I have 4x minus 8 plus 3x minus 5 And I am going to use a calculator for this one just for time's sake. But if you didn't have a calculator, you could easily do this by hand. So all of this equals 308. Then I have 308 minus 8 minus 5. Well, 308 minus 8 is 300, and 300 minus 5 is 295. So I have 4x plus 3x plus 295 equals 540. So really I have 7x plus 295 equals 540. I'm going to subtract 295 from both sides. So I get 7x equals 245 because 540 minus 295 is 245. Divide both sides by 7 and I get x equals 35. However, that is not our answer. And in fact, this is a question, not this exact question, but something like this. In one of our courses, I made a mistake and had to go back and fix it because I just was like, oh, I got the answer, I'm done. And I actually like that I did that because it shows that we all make that mistake because we're so excited to get this problem done and we're so excited and we're like, yes, got it, A. But it's not A because it didn't ask for the value of X. It asked for the value of this angle. And the angle is 4x minus 8. Well, 4x minus 8, 4 times 35 minus 8, 4 times 35 is 140, minus 8 is 132. So the answer is actually B. All right, let's keep going. I see Nehal, you are struggling a little bit with quadratic equations. I will make sure I include quadratic equations next week in our live session. Everybody else, if you missed that note, if you have a specific topic that you want me to go over in our live math sessions, drop it in the comments. I will be happy to add it to my set of problems in the upcoming weeks and make sure that we hit that content for you. So if there's something specific that you want to see me solve, drop it in the comments and I'll be more than happy to add it. All right, last problem of the night. Which of the following could be a point on the line shown to the right? So we have 2, 0, 3, -1, 0, 6, or 12, 6. So I'm going to actually zoom in on this line so we can see it a little bit better. So let's go ahead and just plot these points. 2, 0 is right here. That is definitely not on the line. 3, -1 is right here. That's not on the line either. 0, 6. That's not on the line either. 12, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5 is going to be somewhere up here. That looks like it could be on the line, but fun fact, it's the only answer choice that we didn't cross off right away. So D is going to be the correct answer, but let's pretend we had some other points that looked like they might be on the line. Let's pretend like we had some other points. What would we do? Well, we would find the equation of this line where we know the equation of a line is y equals mx plus b, where b is our y-intercept and m is our slope. And so I can find my y-intercept pretty easily. It's where it crosses the y-axis, which is 2. So y equals mx plus 2. And my slope is just rise over run. So I'm going to look for the next point that crosses through an intersection. So I rise 1 and I run 3. So the equation of my line would be y equals 1/3 x plus 2. And then I could plug each of the points in that I was confused about to solve and see if I could solve and see like which equation is going to work and which equation isn't. So I see that I could plug in the x, the 12, and the 6 and see if it equals. And in this case, it's going to. But like I said, if we had multiple points where we weren't sure if they would work or not, that's how we would solve it. So excellent work today. Dr. A is going to jump back on here and go ahead, and he has a special surprise for all of you for sticking around with us tonight. Don't forget to join me next week on next week's math session. But I'm going to throw it back to Dr. A so that he can close us out and give you all a special surprise. I'll see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.